Today I'm working on one of these Harbor Freight plasma cutters. It's a Chicago Electric 91814. It's for a friend who says that it kind of works part-time and has trouble starting. So the first place I'm looking is at the torch here. Definitely shows signs of age. There's some cracks in the plastic housing here, but nothing that actually indicates that it shouldn't function. It's all intact on the inside. The electrode, as I understand, can have up to a 1/16 of an inch pit. This one's probably right there, so that should still be good. But next thing to change out if I can't find anything else. The ceramic ring is in good shape. The holes are open, and I'm gonna use a brand new tip here. So I'll hook the air up to the unit. This actually will not show power on the LED there unless air is hooked up to it. And I'll put the torch back together and we'll see what it does or doesn't do. Thought I would just demonstrate the tip configuration here. As assembled here, there is some springiness to it. So the nozzle, or rather the tip, will actually fall down into that ceramic band. And the Harbor Freight instructions say that as you assemble it, once you have the outer case on, it still should do that. And here it is installed, and you can see there's just a little bit of movement up and down. Air is hooked up, and you can see we have about 70 PSI on the gauge there. 65 is the minimum specified for this thing. So go ahead and flip it on. You should get a little puff of air out of the torch when you flip it on. That's normal. We'll check the lights. We've got power indication. That's good. The amperage is, we'll just set it to the kind of the middle of the range. And let's see what the torch does or doesn't do. So air is flowing. You'll see no starting. And we are seeing the cutter light is turning on the machine. So it thinks it's cutting, but it's not actually making that, that starting arc. So let's see if it actually can cut. I had to touch it to the work to get it to start. So I can get an arc. If I actually touch it to the work, I can get an arc. Let's see if it can actually cut. Let's touch the work first and then hit it. It's flipping on and off. It really doesn't like that, and it doesn't seem to want to actually cut. I bet if I played with it, I could eventually get an arc, but it's definitely not starting an arc like we expect. Well, I just discovered something. If you have the pressure drop while you're using it, you will see the machine start to malfunction. So normally when you press the button, it goes like this. You hear a click and the air is allowed through the torch. I'm gonna hold it down and show you what happens when the pressure goes too low. It'll start clicking, and that's because you've dropped below the threshold that it needs. Turn your air compressor back on. I've got good pressure and I let the machine cool and everything, so I'm gonna give it one more try and see if I can cut. Yeah, it wants to just make basically like a dead short. No starting arc. Let's open this up and see if there's anything to see. So I've taken the front cover completely off. That does not require you to remove the torch or the ground. On the rear, I just spun it around so that I can access these additional screws. Taking the cover off, and I wanted to loosen it with two hands because there's almost certainly capacitors in here, and there they are, yeah. So those could still be charged. Want to be careful around capacitors when a device has been plugged in recently. So it looks like it's all pretty dirty, but the thing I'm looking for that the internet tells me might be the problem are some resistors that control the starting. There they are. Aha, and it looks like one of them might be shorted, or at least there's some discoloration there that doesn't look healthy. Also a whole bunch of either those MOSFETs or maybe some transistors, I'm not sure, but lots of things to test here, but the first thing I see is that resistor. So I'm gonna get my multimeter and measure that. Got my multimeter in ohms mode. Let's see what we get across these power transistors. There you go. We're looking at like 2K, and these should be like single digit ohms or even less than an ohm. And it looks like they're in parallel, so yeah, the front one and the back one should just be the same. Measuring the back one is the same as the front one. These are in parallel and they are not flowing. So we're gonna have to desolder those and do some research to figure out what value they should be, but I think that is our problem. Well, I've disconnected the torch and the air regulator and brought it inside so that I can focus on these resistors. I'm going to desolder them and then see about what I can do to replace them. Factory solder is always going to be really difficult to deal with. It's going to be no lead, and that actually means it's going to have a high melting point, and the flux is going to help with heat transfer, and it's also going to help with alloying my own kind of call it low temp solder into the factory solder, and that will help with actually being able to melt it. Now that's going to be easy. So I'm just adding solder to basically alloy my own solder into the existing stuff, and now you can see how much more easily it melts. Okay, that last one I'm not going to be able to get to until I get the front resistor off, so let's see if that's possible. Starting with this side. Oh, not so bad. There's one side, and we'll do the other side. How did I get at it? Here we go. Yeah, see, so once you get your own lead-containing solder with a low melting point, these things aren't so bad to take off. Hardest part is just figuring out where I can get my tweezers and my soldering iron in there around the camera. All right, there's two pretty fried-looking resistors. While I'm in here, I noticed that there's another component right next door. This band is almost certainly for measuring current. So it's got ultra-low resistance, and you measure the voltage drop across it very precisely. That's called using a shunt for amp measurement, and it'll tell you how much current's flowing through. But you can see a little spot right here next to my finger where it looks like a little bit of that was melted, and that is further evidence that these resistors got super hot. I'm not going to worry about it. I think I'd probably cause more problems than I would correct if I tried to mess with it, but be aware that that thing needs to be intact. Also, while I'm in here, something else I can see is it looks like there's these two red cables that come off the board. Well, they both go to the port on the front for the torch, that red port. But the one on with the black insulation in the back, it goes to a separate circuit than does this one in the front. And this one in the front is actually the one that's wired into our power resistors. So these things were in parallel, and they start on this side of the board over on the right, and they make the jump over to output on this wire. So I'm guessing what's going on here is the two wires, one is the continuous current for plasma cutting, and the other one closest to us is starting current for starting. I'm in this situation where I don't actually know what the values were of these resistors, that is in ohms and total power handling in watts. So I've read online anywhere from 0.5 ohm to 1 ohm, some plasma cutters apparently even higher than that. So while I don't know how many ohms it takes to make a pilot arc, I know how many I'm going to use, and that is 2. This is a 2 ohm, 100 watt wire wound resistor. The reason I like this is that it can be mounted on the heatsink just like that. So for mounting, it's definitely advantageous. The other thing is that this is available in multiple values. I happen to have a 2 ohm here on hand. If it doesn't work, I can always change this out to a 1 ohm or a 0.5 ohm, and it'll have the exact same form factor, so I can just swap it out pretty easily. I do have these style of resistors on hand. These are 1 ohm, 10 watt each, but I just don't feel like that's much of an upgrade. You know, if I put these in parallel, that would be 0.5 ohm and only 20 watts of power handling. I could maybe do 4 of them and do, you know, parallel and series, and then have 1 ohm and 40 watts, but it just gets ridiculous trying to stack all those up. Plus I can't attach it to the heatsink as easily. So while I have these, and they're probably close approximations of the original resistors that were there, I really just think that this thing's gonna be an upgrade overall, and I'd rather upgrade it. I thought about actually trying to drill and tap this aluminum, but it's just too thin. Being a heatsink, this is just one of the fins, and I don't think it's gonna be holding any tapped threads. So I'm just gonna use these kind of big, dumb, heavy coarse threads and screw directly into the aluminum. Okay, so what I'm gonna do is run these screws down a ways to actually form the threads, and then I will back them out, clean this off really well, and then apply some heat transfer paste. Here's some isopropyl alcohol. Good clean all. What else I want to do is deburr the tops of these holes so that there's nothing preventing that resistor from sitting level. And then I will apply some good old thermal paste, heat sink compound. Okay, so that will help with the heat transfer. Go ahead and just set it down close to where it needs to go. And I'll let these screws help me smush that into place. Next step is to wire it in. So I zip tied this air line out of the way so that I wouldn't accidentally nick it with my soldering tip. And I found this silicone insulated 14 gauge wire, which should be more than enough. I like silicone insulation because it can get really hot and it doesn't melt. So great for soldering. So what I'm going to do is I'm going to strip off some off the end here that I can lay down on the circuit board and actually solder it across the two leads on the circuit board. Something like that full of solder should be able to lay right down in there, and then it'll just fold down, and the other end obviously will solder onto the end of the resistor. Okay, it's all done. I didn't film everything because I didn't want to make this a soldering video, but you can see these wires laid in really nicely, plenty of clearance for the cover out of the way, and should be able to handle a lot more heat with a combination of this big wire wound resistor and taking advantage of the huge heatsink that's here. Next step is to test it out. Well, I got too excited to test this out, and I did so without the camera running, and mistakes were made. I'm going to measure my power resistor here, and you can see on the meter, no ohms registering whatsoever. This resistor is wide open. So I think I know what happened. I think that I actually created a dead short by touching the torch to the material, and that just sent too much energy through this. Recall the power law is P equals I squared R. So watts equals amps squared times resistance, ohms. And this is a 2 ohm resistor. So if you assume, let's say 10 amps going through this pilot circuit, then the power in watts would be 10 squared, which is 100, times 2, which would be 200 watts. And of course, this is a 2 ohm, 100 watt rated resistor, so twice what it's rated. Now, if I had a lower ohm value, like 1 ohm, then that's 100 times 1, that's 100 watts going through here. And at a 0.5 ohm resistor, that would only be 50 watts going through. And I think that is the problem. This value of the resistor is just too high. I found information online that confirms that it appears that there were two 1 ohm resistors in parallel on the board initially. And so two 1 ohm resistors in parallel would be 0.5 ohms. And that's what I have here. So this is a 0.5 ohm, also 100 watt capacity wire wound resistor that should be able to go into the same holes and the same mounting location that I already made. So I'm going to swap this in and see if we have any better luck. Okay, the half ohm resistor is installed in the original location where the 2 ohm was, and I'll just verify it on my multimeter here. 0.56, that seems about right for what the meter can read. And in case you're wondering what's inside one of these wire wound resistors, well, I took this one apart and it's literally just wire wound around a ceramic element. You can see it's this really fine wire, and that determines the resistance. And as for the aluminum tube, well, it's just that. It's an aluminum extrusion that just has the resistor inserted inside, so I can actually reuse this with an arbitrary resistor of my own choosing for another project. I also picked up this set of consumables. It has the ceramic ring and housing, electrodes, tips, and these standoffs for drawing on steel, not actually touching the work. Okay, we're set up on the bench, no cover on, just in case I need to get back in there. Let's flip it on and see if we get any starting arc. There's the air puff that we expect at startup. Not going to touch it to anything yet. Contact. Hey, there's something. So we're getting more than we did before out of this torch, and now I'm just wondering if it has to do with worn out components in the head. Let's try again. Yeah, it's inconsistent. Let's swap those out and see what happens. I'm starting with the most likely candidates, which is this housing and the electrode. So we'll swap those in, but keep the same tip, same ceramic ring. Okay, we're set back up, but still just a little bit of springiness to the tip. Let's see how it does. pretty good. A little bit of delay when I press the button, I get air and then an arc. I think this thing may be operating. So I've been playing around. I think the limitation is on airflow, but let's see if I can demonstrate a cut all the way through here. Almost. Well, I don't get any rewards for metal work, and my compressor doesn't get any rewards for capacity, but I think we've proven that the fix does work. So I'm going to put this back together, and I'll go ahead and do some more testing, but this one looks like it's fixed. Well, this little plasma cutter is ready to go back to its owner. I listed the parts that I used to do this repair down in the description. If you have any questions, throw them in the comments. I'll try to help. And if you found this helpful, go ahead and hit that like button. But in any case, thanks for watching.